computer.
I just have to. Okay. Okay. Well, hello, everyone, and welcome once again to the chat room. Today, we're very fortunate to have with us Mr. Jim Murray, who is an expert on the genius of Nikola Tesla. And we're going to be asking him some questions and getting some inside information. And also, we're very lucky because Jim also did some work with Yul Brown. Uh, as some of you will know, Brown of Brown's Gas, one of the early pioneers of Brown's Gas. So we're fortunate enough to have Jim, who actually worked with him. So we shall, if we have time, we shall pick Jim's brains about Yul Brown as well. So very welcome, Jim, to the chat room. So if you'd like to tell the audience a little bit about yourself and how you became interested in Tesla's work, and then we can get into some of the nitty-gritty. So over to you, Jim.
Well, thank you, David. I'll be happy to backtrack a little bit and give you some insights into my career, if you want to call it that. So I went to school away from home for a good many years, and I didn't like boarding school at all. So I spent a lot of time in the library reading, which was kind of an escape, you might say. And I found a book, was written by the Westinghouse Corporation. It was based on electrostatic particle accelerators. And it really excited the heck out of me. I knew about Van de Graaff machines and stuff like that for a very long time, but I didn't realize that it could be used for something other than just making big sparks. And so once I realized that there was a practical purpose to it, I got very interested. And in fact, I even, in my freshman year of high school, or actually it was my sophomore year, I entered the National Science Talent Search with a linear electron accelerator of my own design, and did very well with that, winning in the school, city, and state of Rhode Island. And then I followed up the second year with another particle accelerator, which I had converted to accelerating positive ions. And I was doing some very fundamental transmutation work. Whether it was actually happening or not is debatable, but I had all the equipment. And I went very far with that. But it was during those years that I came across multiple references to Tesla's work, also with particle accelerators, because as you know, or you may know, he did a lot of work with machines that you could certainly interpret as particle accelerators, even though he probably did other things with them. And so I became very fascinated with his philosophies, and I began reading everything I could find on it. And in those days, I was very fortunate because I was still living in Jersey City. At least that's where my home was when I wasn't in New England. And I used to cross over to New York and visit the main public library, where they had unbelievable volumes of stuff on Tesla, because after all, his main engineering office was right there, only a few blocks from the library. And so one thing led to another, and I found that the more familiar I got with his lectures and his teachings, the more I seemed to be able to read between the lines. And so I got very interested in following up on some of his statements concerning things like energy and power transmission and things of that nature. The biggest problem was it's very difficult to find a clear-cut path between the things he was claiming and all of the ridicule and rejection that he received from the more academic arms of classical physics. And the only remedy I could think of was, well, I'll do it on my own. So I began building stuff and doing experiments to see if I could duplicate some of the things he talked about. And I started on that course of action back in the 60s. I think it was 67 for the most part. And then that's pretty much continued to the very day of today. And of course, I've had a number of companies and a number of business partners, and the work has been very slow because it's still very difficult to find funding for some of the more obtuse ideas that people like me like to pursue. So that's the thing in a nutshell, I guess.
Okay. Okay, well, can I ask you, you did mention it about his work about transmission of electricity, and of course he had something which would be considered very unorthodox, which was a transmission of electricity without wires. So I wondered if you could talk to our audience a little bit about that.
Well, that's actually the beginning of it is actually an outgrowth of his work with resonance circuits. And the reason I say that is because if you take a capacitor and examine it at its most fundamental level, essentially you have two conductive plates separated by a dielectric. And that dielectric can either be an insulating material of some quality like mica or plastic or something, or it can even be air. And if you take the definition of capacity to its limit, you can separate those plates by a very large distance. And then if you apply the proper voltage and frequency, you'll be surprised that you still have a circuit through which electricity is flowing. And so that was, I think the realization of that may have been one of his points of departure into another realm of the idea of how to deal with transmission of electricity, because the first step would be to establish capacitively coupled circuit that had a single wire for return. And I have duplicated that kind of stuff to some extent years and years ago. The next step, of course, is to eliminate the return wire and use the ground as the single conductor. And then you get into a very interesting situation where you suddenly become cognizant of the fact that the capacitance of the circuit takes on some very extraordinary attributes, because you're no longer using simply bound charge, but you're also using unbound charge by virtue of the fact that there's interaction with the Earth's ionosphere and the charges that we're immersed in. And once you get into that, it takes off very, very steeply into some areas which are really, really obtuse. And I could only go so far in that direction because it doesn't take long before it becomes extremely expensive. But I mean, I can elaborate to some extent if you still want to go there.
Yes, I mean, bearing in mind that I would think most of our listeners are not electrical engineers like yourself or myself. So we don't want to just talk in technical terms that only you and I understand. I'd like to sort of at least get an outline idea of Tesla's thoughts on that. to see how he was proposing he could, as I say, transmit energy without electricity. I mean, from what you've just said,
No, not
um,
electricity, without,
sorry, without wires. Yeah,
yeah.
yeah. Now, was he? I'm keep it in simple terms. Was he using? You mentioned a capacitor being basically two electrodes with a dielectric, an insulator, let's say, between them. Now, was he proposing that the Earth itself could be the dielectric between two plates that could be a transmission started in one place on the Earth and picked up through the Earth in another place on the Earth? Was that one of the methods he was thinking of doing?
Well, first of all, in order to answer that question intelligently, believe it or not, it couples into a whole mess of other things, whether we like to go there or not. And one of them is Tesla's work with the so-called earthquake machine. And the reason that I bring that up, even though it doesn't seem related, is because it's actually very related, but it's on a different level of interaction. In order for him to have produced an earthquake in downtown Manhattan, you would have to understand that producing vibrations of that magnitude is one thing. However, producing vibrations that have the ability not to be dampened by their own in the environment that they're moving through is another level of accomplishment altogether. And I, for one, I don't know about other people that are Tesla enthusiasts, but I, for one, like to refer to that as the propagation of a Tesla wave. And a Tesla wave is a very, very different animal. It's not a sine wave, and it's not a lot of other waves. It's not a square wave or a triangular wave. But it does have the very interesting property in that it's capable of paying the tab for its own dissipation simply because of the geometry of the wave itself. And once you have mastered that kind of a thing, now you can, theoretically at least, convert that same knowledge of the wave geometry into other waveforms. They don't have to be acoustic or vibratory, they can be electromagnetic. And naturally, if you do it properly, you will reap a certain amount of success in that other domain, which is nothing more than a different octave expressing the same laws of physics. And so I know for a fact that he definitely was well versed in producing these Tesla waves on a number of different in a number of different formats, or whatever you want to call them.
Would this tie in? I know we've perhaps just moved off target a little bit, but because he's reputed to have developed with various frequencies the ability to set up certain resonances, shall we say, that can disintegrate quite a range of materials, whether it be concrete or steel or anything else. I mean, is that true as far as you're concerned? So that was all to do with resonance, various resonance, in the same way that an opera singer might generate a certain resonance that would shatter a glass. Tesla was reputed to have been able to form certain resonance that could destroy virtually anything. I mean, what's your thoughts on that?
Well, I like to speak from a position of authority, and the only authority I really have are the situations involving Tesla's work that I personally have managed to duplicate. because if you don't rely on experimentation and verification, you're really just, repeating what other people say, or maybe even go so far as to say shooting a lot of hot air, which I don't like to do. Now,
Mm.
I have never accomplished that kind of destructive power, nor had I any interest in doing that.
Mm.
So most of the stuff that I rely upon were little hints that Tesla dropped about certain things, which took me a lot of time and effort to understand and then duplicate. And even the duplications were in very limited form because I've never had a lot of money at my disposal. And so when you don't have money and you're very persistent, what you do wind up doing is spend a lot of time because it has to become like a hobby or a continuously progressing side effort, which takes years sometimes. I'll give you an example. The first job I had of any significance was for an electric car company in Connecticut, and they claimed, or one of the principals claimed, to have been working with ideas which descended from Nikola Tesla. And that was in 1965. No, 67, I'm sorry. And I'm still working on those problems now because they require the total engineering of prototypes that nobody in their right mind would ever build. And not only that, but years and years of trying to figure out the meaning of certain differential equations and things which nobody bothers to investigate because they're not related to anything, at least normal things. And so you wind up sacrificing time when you don't have money. Money compresses time. But one of the things that really inspired me after having looked into some of that stuff, believe it or not, were very fundamental ideas that Tesla put unusual emphasis upon and which seemed to be completely outside his normal realm of activities. And one of them, which I found in the main public library in New York, the first time I think I was exposed to it, was his preoccupation with the rotations of the moon. And I said to myself, what in the world does that have to do with anything? And it's taken 40 some odd years to really understand what the man was driving at. And it's such a convoluted story that, we probably don't have time to investigate it in detail in this little talk, but it's a very, very fascinating situation because it leads into epicyclic engineering and, the basic properties of certain types of planetary gear arrangements and why that has a bearing on Tesla's work. It's very involved.
Can you give us, I appreciate that that would be a very complex subject on its own. I mean, Jim, can you give us a little thumbnail sketch, shall we say, of where you think that sort of work would lead? I mean, I know just from what little bits I know about Tesla's work that he was interested in and working on some quite bizarre things, even time travel. I mean, I don't know how much you've been able to untangle some of the things that he was working on. I mean, obviously, we know that straight after his death, the FBI, no less, invaded his workshops and took all his papers and equipment away, or so the story goes. And that was within sort of about a day of his death. So there was obviously something of great interest to the state and the military in whatever Tesla had been working on. And we're just left with rumors and speculation. So it would be very good if you can put some meat on the bones on any of those aspects. if you could, Jim.
Well, sticking with the subject that I wound up inadvertently introducing, this whole thing really boils down to the fact that Tesla believed, and I believe also, by the way, as a consequence of all these years of working, that power can be amplified in ways that are not believed in by academia. Because in a normal situation, for instance, you have an input which you got to pay for, like speaking about an audio amplifier, for instance, you got an input from a microphone and you got an output at a loudspeaker, but you also have 110 volts delivering power to the amplifying stage. And so there's no mystery there. You're bringing the signal up at the cost of bringing in outside power, which is totally acceptable in normal thinking. Tesla, on the other hand, believed that under certain circumstances, energy could more or less be, and I should really qualify that statement, it's not the energy itself, it's the work that energy can do, can be amplified by certain natural phenomenon, which are free. And so, that becomes the real crux of the issue. And I believe that's primarily where Tesla was focusing most of his attention. And if you read everything that was written about him, as well as the books or the articles that he himself published, you can find little hints here and there that that's exactly what he was attempting to do. Extracting work from the ionosphere by virtue of the charge produced by the sun's influence on our atmosphere is a free thing if you can do it. But there's other aspects of that which are just as free and just as complicated to achieve, and that's doing the same thing either electrostatically or electromagnetically, which is equivalent of extracting work from an intrinsic field. And you can't do that.
Yeah, sorry to interrupt there, Jim. Would this at all tie in with the work of Wilhelm Reich with what he called orgone energy, and to be able to tap into that? I mean, I've seen people producing motors and using very long aerials up into the sky. So it's basically, some people call it atmospheric electricity, and they've built certain motors that will run on it. Now, this atmospheric electricity may be one and the same as what Wilhelm Reich would call orgone energy or life energy. Does this make any sense with what Tesla was working on as an additional free input into a more earthbound circuitry, shall we say, if that makes sense?
Well, you got to realize that a lot of people over the years have discovered the same stuff and they give it different names. And so that complicates the issue. I mean, orgone itself has been called all kinds of different names, going back even to the time of Mesmer and other people. And so I assume that the same kind of thing is probably happening with some of the stuff that Tesla christened with his own titles. But I don't think that you can deny the fact that there is definitely energy available. It's a question of how do you get to it? There are always seem to be little hitches that prevent things from, from being capitalized upon. And then even the restrictions that are imposed by physics itself are nothing compared to the restrictions that are imposed by the establishment who don't want us to have that degree of freedom. So it's an uphill battle, no matter how you look at it.
I mean,
But
that was, sorry to interrupt again, that was the downfall of Tesla himself, wasn't it? When, commercial interests, and I'm thinking of probably JP Morgan and probably Westinghouse and others at the time, realized that what Tesla was doing um, was, in their words, they couldn't meter it, i.e., couldn't charge the public for the energy that could possibly be produced. Um, and obviously, I think that was in the end the downfall of Tesla, where his funds dried up. I mean, you may be able to enlighten us a little more on that.
well, I think a lot of that was an excuse, and I'll tell you why. You got electricity flowing in a circuit. I don't care where it came from, you can meter it. So there's no reason why they couldn't have made use of Tesla's form of power transmission and metered it at the consumer end and sent them a bill anyway. But I think that there was more to it than that, because if you could do that with the Tesla's technology from a central point somewhere in the United States, let's say, there would be nothing to stop entrepreneurs from saying, well, let's have 10 stations, let's have 100 stations, let's have 1,000 stations. And now it becomes a little bit more complicated, because you're approaching the realm of independent power, and it's really about control and not profit when you get to that point. They don't like us to have control over our own lives. And that's what it really comes down to.
Yeah, exactly. And but I mean, there's always a profit factor in that, isn't there? Control and profit sort of go together. I mean, would it be fair? I'll ask the question. I mean, from what little I know about Tesla, he seemed to be very much a humanitarian. He seemed to be motivated by humanitarian philosophy, that he wanted to make things that he was discovering available to the general public. Would you say that's fair, or is that maybe the wrong story?
Oh, I think that's very true. As a matter of fact, he's very lax in a lot of his business practices, and he didn't really care about the small things that were usurped from him, which others made fortunes on, and he did not. But I think that's mostly because his focus was on the much larger, almost global, uh, utilization of his technologies for the assistance of mankind in general.
Mm.
And I think he also was very cognizant of his own mortality, and he only had so much time to do all that. And so he let the small stuff slide, but other people certainly didn't. I mean, look at Marconi. That whole story is, really worth putting out there, even if nothing else is, because there was nothing in Marconi's work that didn't have its origins in Tesla's technology. And when he first applied for patents, they were all rejected on the basis of Tesla's prior art.
Mm.
And then when Morgan got involved, miraculously, the patent people changed their mind, and they issued all sorts of patents in Marconi's name, which then became the basis of forming the RCA Corporation. And we know where all that went. So, money talks, and everything else walks.
Yeah, yeah. Okay. Well, if I can just come back to what we were talking about, sort of power transmission. I don't know whether you can enlighten us a little. Again, with what little knowledge I have, I believe that Tesla worked with some extremely high voltages and extremely high frequencies. I don't know whether you can tell us a little bit about that.
I don't think that most of the frequencies that he played with were as high as the ones that we're using today. They were definitely in the kilohertz range, but I don't think they went into the gigahertz range.
Okay.
And as far as the voltages are concerned, they were extraordinary. And he had secrets for manifesting unbelievably high voltages. And I don't think anybody, myself included, fully understand how he did some of that. But the combination is pretty amazing. And you have to realize also that he dealt with full electric components um, in his researches with electricity. We are pretty much focused on the electromagnetic portion of electricity, but there's also a dielectric component of electricity. There's also longitudinal waves in addition to the normal Hertzian waves, and people are still arguing about that. But if you look at the distributed capacity in a normal coil that can allow it to be self-resonant, you will find that those parameters manifest by longitudinal means and not by transverse means. And so to argue that there is no such thing is foolhardy. But without putting in a whole mess of time and effort and huge volumes of money, I don't know that we're going to be in the position to duplicate all of that unless the time eventually comes when whatever was stolen from him is made available to the public, and that's debatable.
Yes, I think, as they say, hell will freeze over before that's going to happen. But okay.
I pop in here and ask Jim a question?
Sure, yeah.
Yeah. Jim and I, for people who don't know, go back a long, long way. And many times in restaurants that Jim has explained a lot of his theories just on a napkin to me, and it made perfectly good sense. So I want to sort of talk about that a little bit. If you can talk a little bit, and I know you hate the term, Jim, about free energy. I think people are sort of interested in that idea. It's more, I would guess, efficiency. Like when you had your Dynaflux generator, people came to see it. You could demonstrate that it was more efficient, but not necessarily free energy. So could you talk about those concepts that are not literally free energy, but where you get more efficiency out of something?
Well, yeah, but I'm going to do it from a different perspective a little bit because otherwise it becomes very confusing very quickly. I mean, the reason I don't like the term free energy is because all energy is already free. On the other hand, you got to pay for all of it. So it's a very, misleading term. On the other hand, what does make sense is if you have a situation in which you can have a gain in work function for a particular volume of energy. Now you're talking about something totally different. So that kind of falls under the umbrella of efficiency, but in a very different way, because the normal understanding is you got a certain amount of energy at your disposal, and you convert it into work by allowing it to do something. And now there are, relationships which govern how much work you can get from a specific supply of energy. And that becomes the limiting factor that our present technology recognizes. But the interesting thing is, if you study what the real law says, it says that energy can neither be created nor destroyed, but only change from one form to another. But then they stop there and they don't tell you the rest of it. And the rest of it is that there's no limit to how many times you can do that, providing that you can effectively manipulate the energy that you have on hand. So our tendency with our society is to do it once and basically throw it away because we feel that you can't get it all. But what Tesla concentrated on was, okay, you do it the first time and then you reverse the process. You do it again, you have less. You do it again, you have thoroughly more or less. And you keep on doing it until you truly have nothing. And then you take another input and start all over again. Now, when you do that, the work that's done is completely different and not related to the original input of energy by the same numbers. And so you could argue that under those conditions, your efficiency goes way up. That the overall efficiency, or in other words, the total work produced by a specific volume of energy now becomes greatly magnified. But there's nothing in nature that says you can't do that. It's just the way we decide to approach things that limits us.
So if you can, I don't know about the propriety aspects of it because I know it's been a while. Can you explain to us how you accomplished that with the Dynaflux generator that you patented and made it quote unquote more efficient? What was going on there?
It's in the public domain years ago, so I don't have any problem with that. But it's all based really on the restrictions that we recognize in the normal design of a generator, which pretty much embraces Lenz's law. And for those people that are not familiar with Lenz's law, it basically says that when you have a current carrying conductor in a magnetic field, force appears which will attempt to oppose the motion of that conductor in that field. And so when you have a generator that's spinning away and it has no load on it, it's consuming very little fuel, or whatever your input is, whether it's wind or sun, it doesn't make any difference. It's consuming a minimum. And then all of a sudden you throw a load on the generator. Now you're pulling a strong current. That current crosses with the magnetic field and produces a torque. The force from that torque opposes the very velocity that you're trying to maintain in order to continue the generation process. And so now all of a sudden your consumption rate goes way up. So basically what Tesla did with some of his equipment, and which I attempted to do with Dynaflux, was instead of continuing the motion in a circular fashion, which most generators do, I envisioned a generator that had circular motion components, but generated electricity by means of an oscillatory component, which went back and forth with simple harmonic motion. And if you do that correctly, what happens is that you wind up reversing your force, your driving force, at a moment in time when your current is a maximum in the circuit. And what happens there, which is fascinating, is that the Lenz's law, which has been opposing you for the first portion of your cycle, is suddenly operating in the same direction as the redirected oscillatory component. And so now it helps you. And once you do that, the mathematics changes drastically, and so does the efficiency. Because instead of fighting you all the way, it fights you half of the time and helps you the other half of the time. And for some reason, people have a lot of trouble with that concept. I know I spent a lot of time and many years trying to sell the idea, and I think I had one or two takers, but nobody threw any money at it, so it disappeared.
I remember.
course, it didn't disappear entirely. I mean, I'm still
I know.
working with the same concepts, but from a different perspective.
Well, when you did demonstrate it to them, what was the resistance? You showed them. I remember watching the videos and seeing the machinery and you demonstrating the greater efficiency. So where do you think they stopped? In other words, why couldn't they get it?
I don't think that they couldn't get it. I think they did get it, and it was very terrifying for some reason. And you're probably better equipped to explain that than I am, because I'm sure it has to do with psychology and
Yep.
with self-image and the investment of time and life into your PhD degree and all that nonsense. But anyway, I'll give you a typical example of what happened. I got a grant from I forget what institution it was, to build a presentation model of the Dynaflux concept. And that was way back. That's got to be 40 years ago. And George and I took that challenge and took the money and built a beautiful presentation prototype. And the only caveat that they imposed was that we'd have to work with a guy from one of the major engineering schools in Pennsylvania. And he was a doctorate of physics, and he was going to oversee the whole thing. And that way there wouldn't be any problems. And I said, that's fine, I don't mind, So I designed everything, built everything, and then we brought it all down to Pennsylvania, set it up. And this guy more or less gave the orders, like he was the head honcho. And he had a little notepad there and a calculator and everything. And as we were going along, increasing the load on the system, he was furiously taking notes and playing with the calculator and writing down numbers. And when we were about halfway through the thing, he stopped and he said to me, "Say, he said, there's something strange here." And I said, "Really? What's that?" And he said, "Well, this machine puts out more power than it takes to run it." And I said, "Yeah, I know. That's why you're here." "Oh, no," he said, "you don't understand." He said, that's not possible. Therefore, it must be doing something else." I said, "Okay, so what's it doing?" And he said, I'll have to get back to you on that." And I was 40 some odd years ago, and never heard boo from the guy. So I don't understand, what that realization instills in a person's mind. But for me, it's a wonderful feeling of, oh, see, it does work. But for somebody else, I think it's very threatening. And you probably know why more so than me.
I do, but we're not talking about that here. So, but I just wanted to go back to the Wilhelm Reich stuff and Orgone Energy for a second.
Sure.
Reich claimed, that Orgone Energy was a mass-free energy. All other forms of energy were secondary to that. Okay, so my first question would be, do you agree with that? And if you do agree with that, how, if at all, does the understanding of that manifest in your work?
Well, it doesn't manifest in my work at the moment because there are certain things I haven't solved. But to answer your question as best I can, let me put it to you this way. I believe that orgone, whatever it is a precursor to both electrostatic and electromagnetic energies. And it's very evident in the electromagnetic realm. I think electrostatics may be a little bit more complicated, though I spent a great deal of time looking for the connection between magnetism and orgone. And of course, one of the problems I ran into was very hard to figure out what the connection is if you don't know what one of the components are. And so you say to yourself, okay, let's assume that orgone energy gives rise to magnetic energy. That's great. what the heck is orgone to begin with then? So you try to work backwards from magnetism to something that will rear its head and say, hey, here I am, I'm orgone. And that's very complicated to do.
Well, it's interesting you bring that up because I periodically go over Reich's books. One of the experiments, the experiment, well, it wasn't an experiment, actually, it was a serendipitous discovery. For those people who are familiar with Reich or unfamiliar with Reich, he was able to discover, these things called bions, which he felt like were the transitory forms from, matter to the living. And he demonstrated that with charcoal and dirt and foodstuffs, whatever. Okay. But at that time, he didn't come to the conclusion that orgone energy was universally present. The thing that kicked it over was he was in his lab and somebody was visiting the lab and he asked one of his assistants just to demonstrate the bions, just to take some dirt, whatever it was, heat it to incandescence, put it under the microscope and show how the bions showed up. And by mistake, that person took sand and heated the sand to incandescence. And as a result of that, he saw these very, very bright blue bions. They were like in a packet, like 3 by 3, very, very strong. And the energy permeated the lab tremendously. You could feel it. It was a super duper high charge. But one of the interesting things that hit me was the fact that he said that all the metallic things in the laboratory suddenly turned magnetic because of that. So take that and run with it.
Well, that's very interesting. I wasn't aware of that, but it doesn't surprise me entirely because, Tesla came out with a very interesting statement in one of his birthday interviews. He used to be interviewed by the press every year on his birthday, and he'd always come out with some staggering information or whatever. And one of the things that he said that actually relates to that is that he viewed the electron, or I shouldn't say the electron, he viewed electric charge as being a combination of mass and charge, which gives rise to the electron concept if you're examining a single electron particle. But he said in his work, he managed to tear the charge off of the mass and deal with massless charge.
Wow.
Now, massless charge, I don't know anything about it because it's very difficult to imagine what the heck that is, but that might be orgone.
Oh.
I think from what we know about Reich and orgone, I would think that would be correct because the orgone is massless, isn't it?
It's mass free.
Mass free. Yeah.
But what Jim, I think, and not to be contradictory, but what you're saying is he took the charge off the mass. Does that make the mass free?
No, he
Because it would have to be energy.
He discarded the mass because it's cumbersome. It's got inertia.
Oh, I thought it was the other way around. Okay.
Yeah.
No.
So the interesting thing is when he started doing those things, all kinds of unusual effects were produced. And I'm convinced that some of them he never reported on. But I can tell you what it's analogous to because somewhere in my readings, I crossed paths with a description that lends clarity to that idea. And you're a tennis player, not you, David, but this guy. So you can appreciate this. If you're playing on a tennis court and you have a puddle and the tennis ball rolls into the puddle, you know how you get the fur gets wet. And the first time you swap that sucker with a good drive, it dries the ball and the water actually falls to your feet or nearby. I know this, I've tried it. And so if you have high enough voltage and high enough frequency to where the the oscillatory component of the force reversal on an electron exceeds its mass's ability to respond by acceleration. That's very similar to what you do when you whack a tennis ball that's wet. You're going to tear the charge off that other thing, and you don't care what you do with it. You want the charge. And so then you can deal with that independently. And I believe that Tesla actually did that. So he may, in some fashion, have actually been using orgone on a very huge scale. But I don't think anybody has ever made that association.
You know,
Except maybe you and me.
it may it kind of sounds like the mass is the host, for the charge. So my question is assuming that that can happen where Tesla can separate the mass from the charge, what happens to the charge? Does it just dissipate, or is it something that can be
That
controlled?
winds up in your circuit.
That what? I'm sorry, I didn't hear that.
Charge winds up in your circuitry and the mass is discarded. That's very similar to what, if you can picture the wet tennis ball being an analogous situation to the planet Earth, which has an orgone envelope. If you could remove the orgone envelope, you'd have a pretty dead planet.
Right.
Okay, so now the next question is, so why does the planet draw in the orgone from deep space or wherever it comes from these orgone streams? And I think in my own understanding of it, simple as it may be, I think that what really happens is these orgone streams wind up impinging upon mass, and they wind up endowing it not only with orgone, but with other physical attributes, like rotation, for instance.
Yeah.
I think the planet is turned. It isn't just spinning. It's been spinning for the last, 6 billion years or something like that. I would venture to say that between the atmosphere and the friction imposed by the oceans and stuff like that, if it didn't have an input, it would have stopped spinning a long time ago.
Yeah, well, I think the concept that Reich talked about, and I know you're familiar with this, of cosmic superimposition, he's basically claiming that that's how galaxies are formed, that's how matter is formed. So you have two energy streams attracted to each other, and then when they slow down, they freeze and they become mass. If you combine that with his theory of energy going from areas of going from areas of low concentration to high concentration, if you kind of imagine the planet as being similar to a cloud, okay? Because the cloud is a higher charge compared to the atmosphere around it, if the planet is a higher charge compared to the energy in the universe, would not the energy be attracted to the planet and sort of feed it and make it turn?
Sure, but that's only half of the issue, and that's the thing that I think is so interesting. You have an anabolic energy profile and you have a catabolic energy profile, and our technology is all based on the downhill decay of whatever energy you want to play with. But everybody ignores the fact that in order for the universe to work, there has to be a building up of everything in the first place.
Yeah, well, that's what, yeah.
And so the entire picture is a combination of both. And yet, pig-headedly, we insist there can only be a catabolic or a thermal decay aspect. And if there's anything else, that's in God's hands. And I don't believe that.
Yeah.
I think that it's put there for us to explore, just like everything else is.
But with Reich's TO minus T experiments, he basically, threw the second law of thermodynamics out the window, because you're creating something passively just by layering the box between organic and inorganic material, comparing it to the atmosphere and seeing that there's a positive temperature difference. So some energy is being created there. So things are not obviously in a state of, just going downhill, entropy.
He demonstrated that to Einstein himself, didn't he?
Yeah, absolutely. But
Yeah,
Einstein was
Einstein
fascinated.
he was blown away by it. But it doesn't really violate the second law of thermodynamics because there's a second input to the system.
Explain that.
Well, okay. So going back to my initial statements with an audio amplifier, you got a microphone and you got a loudspeaker, and you speak into the microphone, and the noise that comes out of the loudspeaker is 100 times greater. But that doesn't happen by itself. There's an input of electrical power to the amplifying stage itself. Okay. So when you create the Orgone accumulator geometry, and you have the alternating layers of organic and metallic structure, okay, that's sucking in orgone from the outside.
Right.
And that's going to be at a different potential due to that sucking action than the quiescent orgone that's surrounding you in the lab and everything else, which is not layered. And so the result is a temperature difference.
Well,
So
would you say that the Earth could be like an orgone accumulator, and that's what attracts the energy and makes it go around? Let's say if the core of the Earth was mostly metallic, molten something or other, with a lot of metal, and the surface was more organic material. So we know that organic material attracts orgone and holds it, and metallic material attracts it and repels it. Is it possible that the way the Earth is structured is sort of like an accumulator, and that's what pulls the energy in?
sure, it's possible. I don't know enough about it to make any dogmatic statements. But what was the name of that guy that wrote the book Atomic Suicide? I always forget his
Walter
name.
Russell.
Yeah, Russell. He talks about the kind of structure that causes a vortex.
Mhm.
We already know that the arms of the galaxies are vortexian in nature. So if it forms a mass at the center, why wouldn't that be influenced by the very vortex that created it? It's the same thing with the planet. It's spinning, and it's got a propulsive mechanism which everybody prefers to ignore. And of course, it does other things too, like sustain life, little things like that.
Well, how would you explain it?
You mean from the standpoint of physics or from a standpoint of Reich's perspective?
Well, both, and Tesla. Let's take Tesla, Reich, and the standard explanation, and I don't know what the heck that is. What makes the Earth go around?
Well, I'll give you an example of what it's analogous to. So you certainly know about Tesla's rotating magnetic field. So if you create a set of windings, it's either two-phase or three-phase or multiple-phase, and you energize it properly, you're going to get a spinning magnetic field. Now, when you put something inside that magnetic field that has the ability to conduct the magnetism, it's going to take off. It's going to spin. He had a big demonstration at one of his World's Fair things where he had a metallic egg-shaped thing, and he put it in this carousel of coils, and it would just take off and spin, and then it would stand up and do a population inversion and all that good stuff. He called it the egg of Columbus. I don't know what it had to do with Columbus, although he did have egg on his face for a number of reasons. But it's the same idea. If you have a magnetic field that's spinning and it invades a metallic structure that has a higher permeability than the surrounding air, it's going to generate inside of that its own magnetic field, which will latch on to the magnetic field on the outside and get dragged along with it. That's the basis of all three-phase motors, really.
Yeah.
So I don't see any reason why you couldn't have a higher octave of that same idea operating with orgone fields that are also spinning and converging and doing or producing Vortexian motion. The only difference might be that it wouldn't necessarily be restricted only to metallic objects, but perhaps to such things as rock and stone and earth and water and everything else. Because after all, the hydrogen atom is the common denominator to every form of matter that we know. And I think that there's some kind of a very interesting relationship between orgone energy and hydrogen.
Well, that kind of leads us to Brown's gas in a way, but
There you go, right there.
before we go to that, and we're definitely going to go to that, if somebody asks you, and I'm asking you, so I'm somebody, does the traditional theory of magnetism, okay, from a classical physics point of view, explain magnetism?
Only in certain aspects, like for instance, permanent magnets or induced magnets that are produced by winding a winding around a steel bar or something like that. When you energize that coil, it has a tendency to line up the magnetic domains in that bar. And so their individual components become additive. And, you know, the flux that is particular to individual domains is suddenly unified, almost like a laser. And they add up and become a very powerful external field. But that doesn't really tell you what magnetism is. It just tells you what it does.
That was my question. So you have the answer to the second part?
I'm sorry, what was the second part?
Well, if that doesn't explain what magnetism is, what you just described, then what is magnetism?
Well, I don't know for certain, but I honestly believe that it is some kind of a spin product involving orgone and physical motion. Because even if you talk about something as mundane as a bar magnet, especially an electro bar magnet, there's something there to begin with, and it's magnified or brought to a higher form of intensity. And so whatever it is, it's pre-existing what you're doing, and you're just ordering it. And so I have to assume that something in our environment is a key component to that. And it certainly isn't normal stuff like air or water or whatever. It's got to be energy based. And the only thing else that's there, even though it's not recognized universally, is the orgone itself.
The Reich's concept of cosmic superimposition, you know, I mentioned this before. He claimed that was a basic function in the universe. You know, that's happening all the time in the universe, on this earth. We see it in plants, you know, the way the leaves grow spirally, you know, the golden ratio, all that stuff. We see it in sexuality, same thing, the drive, you know, for energy streams to merge. If we understood cosmic superimposition better, would you agree that it could explain all these unanswered questions, like about magnetism, that we have, if we understood cosmic superimposition better?
I think if you add one little thing to that to clarify it, that my answer would be yes. And that is, it's not just cosmic superimposition, but to understand it from our perspective, it would have to be how it affects mass. In other words, what happens when it creates enough mass by its action so that you start to build a planet or a star or whatever else it's doing? You have to have a net result in order to judge what the key components are actually doing. I would say if you try to investigate it, in the pure Oregon stream state, it's a much tougher problem because you can't even go there. You know what I mean? But if you could figure out a way to investigate it on Earth or its effects on Earth, I think that would be really, really important work.
Yeah, I was going to say it would be easy to do. Obviously, it's not, but it's just occurring every place. Like when Reich built his Oregon Energy accumulator room, okay, and he sat there for hours, and first he saw these bluish grayish vapors, but then he saw, these pinpoints of light once his eyes accommodated after 3 or 4 hours, and actually saw the superimposition taking place. And when we sit outside, on very clear days where you see those little dots, and he invented what he called an organoscope that was magnified these things, so he knew that it was outside of him and not, coming from inside his body. And you can see these things superimposing the dots, and they go in what he called spinning waves, which is also, a part of the common functioning principle of cosmic superimposition. But of course, it's not two-dimensional like when we see galaxies. There's a lot more going on there. And, Jim DeMeo, Walter Russell, I'm pretty sure from what I read, figured out, most people think that here we have the sun and our planets are going around it and they stay in the same plane all the time, when in fact it's like a corking mechanism, that we're going in and out, the planets, compared to the sun. So it's not just a level orbit. And I think there would be a tremendous amount of clues in there, to help explain everything else away.
Well, first of all, you're absolutely correct about the real geometry or the real spatial motion of the universe. It's impossible for it to be as depicted in little kids' astronomy books,
Yeah.
because the sun is moving at a known velocity and it's dragging everything with it. And depending upon, their individual moments of inertia, they're really going through space with corkscrew motion, not, straight paths of any kind. And so even that is not taught in school. It's something you come to later on when you really get into all this stuff. But yeah, I definitely agree. It's more complicated than most people like to admit. And we don't do ourselves any service by ignoring what nature has put in front of us just because it's more convenient. I mean, just to give you an example, and I'm sure David will verify this, in a situation where you're studying electromagnetics and their effect on various alloys and whatnot, you want to do a BH curve or an excitation curve to determine how much flux you create with so much current and so many ampere turns. And the interesting thing is that they're all nonlinear curves in reality. But when you do certain types of engineering, they say, well, yeah, but that's so complicated, it's so inconvenient. Let's just use this little portion of the curve right here, which is almost linear, and we'll design everything according to that. And now you have an artificial set of conditions that you're imposing on whatever you're designing, which doesn't include all of the the parameters, you might say, that were originally put there by natural means, like, the creator itself. whatever that is. And so we have a tendency to chop things up to get a better understanding. And in reality, you shoot yourself in the foot. It's like what we do with animals when we're studying comparative biology, right? Or anatomy. The first thing you do is cut the thing to pieces and look at little chunks. Well, you know, if you take a rabbit or a cat and you do that, the question arises, do you really have a cat or a rabbit after you've done that? Are you really studying what it is? That's a debatable issue.
Not really.
I do it. I do it in. They do it in the medical industry all the time, don't they? Take parts of a human body to study and think it's going to tell them what the human body really is, or what disease is, or what illness is. And whenever you take, or even blood samples, you know, you can take blood away as they do, or they take sputum away from someone's lungs and then try and diagnose that to tell you what's wrong with the body. Well, once you've taken something away from a living human body, or a cat or a dog, it changes. It becomes something else. So you're never going to have the full picture. And like you just said, Jim, if you do it in engineering and you just take bits of information which suits your purposes, well, you know, so you're chucking all the rest of it away. So, yeah, it's done for convenience, but it doesn't get you to the truth. That's the thing. Anyway, if we
more inclusive than our pathetic little, you know, appreciation for what we think we know. It's mind-boggling.
How tuned into orgone energy do you think Tesla was, Jim?
I'm sorry. Say it again.
How tuned into orgone energy do you think Tesla was, if at all?
I really don't know, because he never mentioned anything like that specifically, except when he went into these little excursions on things like massless charge and, you know, and certain aspects of his reality, which naturally has different titles attached to it than the terms used by Wilhelm Reich. So it's a guessing game at this point. You know, I really don't know the answer.
Yeah, because he made such incredible discoveries that seem to be maybe hundreds, if not thousands of years ahead of his time. And you would think that the reason for that was that he was dealing or understanding energy in a way that we just don't comprehend it.
Oh, well, I guarantee you that that's true. There's no question about it. I mean, just the things that he has written tell you that. You know, a perfect example of that is he was suing somebody on Long Island for trying to utilize a design for a transmitting station that he did not license. And so they had this really big court issue over that. And the opposing legal team deposed Tesla and under oath, and asked him all these engineering questions, which he answered pretty gingerly, you know. And it's all on record. You can look it up. I have a book right here someplace that actually addresses that issue. And one of the questions they asked him was what he projected as the efficiency of his plant design with respect to the standard understanding of early radio transmitters. And he said, well, he said, in my designs, he said, I can put in a couple of hundred horsepower and get out a couple of million in response, which of course allows me to send the signals, you know, much farther and with much greater integrity than the standard approach. So the other I guess it was a professional witness with an engineering degree, and he says, "Oh, well," he said, "naturally, you're referring to instantaneous power, which can take almost any dimension, you know, but it's for a much less amount of time, of course." And Tesla said, "No, I'm referring to continuous power, which will give you that effect indefinitely." And they were just blown away because everybody says, "Well, we can't do that." But that's on record and it's under oath. And, a lot of the things that he did were definitely indicative of having more power available than you could account for. That's pretty darn certain.
So I know that we're going on, but I don't want to not talk about Brown's gas. So maybe this should be the takeoff point, unless David has any residual questions here.
I'd just like to ask one question and then move on to Yul Brown. To ask you, Jim, out of all the things that you know about Tesla, what would you say was Tesla's, in your view, what would you say was Tesla's most important discovery?
Well, that's a tough question. I would have to say it's probably more than one, but I would say that his fundamental understandings of things are what gave him the enormous latitude that his life's work was then capable of manifesting in our world. And that starts with some very, very fundamental things, like understanding transients, for instance. I spent years studying transients because I knew they're important to him. Relativistic mechanics. What's happening in one reference frame is not necessarily what's happening in another reference frame. And when you start to play that game with electromagnetics, you see some pretty fascinating things. I'll give you a very simple example. Let's say you have a bunch of kids on a merry-go-round, and each one of them is holding a miniature, like a miniature globe on an insulated stick. And those globes are charged with 1,000 volts each. Well, if I'm on the merry-go-round with those children, and I have a high voltage detector, I will see electrostatic fields around each of the globes that those kids have. Now, I'm not going to do anything different except step off of the merry-go-round. And now when they're going around, I see a magnetic field. I no longer see the electrostatic field. And so relativistic aspects play a very big role in all of this. And Tesla did not embrace Einsteinian relativity at all. As a matter of fact, his mentor in that field was Boskovich, who lived 100 years before he did and wrote 1,000 volumes in his lifetime based on his own studies. And one of them was on relativity, believe it or not. And Einstein usurped some of his concepts from Boskovich also. And the thing that I get the biggest chuckle out of that is modern physics poo-hoos alchemy. And yet Boskovich was a recognized alchemist. And here we are stealing information from an alchemist to create modern relativistic physics. And then we're telling the rest of the world that alchemy is a useless pursuit. It's a messed up world.
Okay.
And now,
Okay.
So,
Okay.
gas and hydrogen, take it.
Well, this goes back a lot of years. I was introduced to a guy named Kneifel. And he was the one that told me about Professor Brown. He told me about a lot of other stuff too, but that's not relevant to this conversation. But when I heard about Brown and all the things he was supposedly doing, I said, there's no way I can leave this untouched. So I found out where he was, and I went to see him. And he was in Encino, California at the time. And I just called him up one day. I forget how I got his number. I called him up one day and told him I'd like to talk to him, and that I was doing research of my own, and I'd be happy to come out there and spend some time with him. And yeah, he said, well, all right, come on out. So I did that, and he showed me his lab, and he showed me all kinds of interesting things. And I wouldn't say that we hit it off really well at that particular meeting, because I didn't see eye to eye with everything that he was professing. But I was really impressed with his work with the gas. And he then proceeded to tell me where he got the information, which is really amazing. Apparently, he had been, I don't know what his religious background actually was, but apparently he was in a monastery in
Bulgaria.
Yeah, Bulgaria. And one of the assignments he had was assistant to the main librarian. And they were getting all these old books and stuff organized. And in this one dusty room, they found all these scrolls. And one of them, maybe even more than one, but certainly one of them, was an alchemical treatise on water and fire. And I don't know if you had to translate it. I don't know if it was in Greek or Latin or what it was, but anyway, he studied that, and that brought him into the understanding of Brown's gas, or the ability to produce it. And he knew ahead of time what some of the properties were going to be. And there again, we got something that's forthcoming from alchemy, which is very interesting. But anyway, I was working with a guy at the time. I almost don't want to mention his name. He's not high on my list of people to admire. But anyway, I was working with this guy, and I went back to him and told him about my visit with Professor Brown. And so he said, we have to have that man on our team. And so he bought 2 additional tickets to California, and we both flew out there to see Professor Brown. And I said to him, well, you know, he was very emphatic about staying in California, working alone and all that kind of stuff. And so how are you going to convince him to come to New Jersey? So he opens his little bag that he had with him, and he takes out 2 cylinders of black plastic that were about, I'd say 9 or 10 inches tall. Puts them on the desk, and he said, I believe this will do the job. I said, really, what the heck is it? So he unscrews the tops on these 2 plastic cylinders and pours the contents out onto the table. And there were, I forget how many, but there were $10,000 worth of gold coins in those 2 containers. So I said, oh, so you're going to seduce the man? He said, absolutely. So anyway, as it worked out, I'm not going to belabor the issue. It worked out that he gave this gold to Professor Brown, and we had a long visit, and he talked about all kinds of things, and we toured his lab again and whatnot. And by the time our return flight was landing in New Jersey, a signed contract was coming out of this guy's printer at the other end. And he said, see, money talks. So anyway, that was the beginning of a pretty interesting association. And it lasted for about 3 years before Professor Brown threw in the towel and decided that he was going to go back working on his own. And so during that time period, I learned an awful lot about Brown's gas, and I designed and built really unusual equipment that made use of those properties. And I think that the most amazing thing that we got accomplished, I mean, I'll go into the rest of it if you want me to, but I think one of the most amazing things that we accomplished during that time was the the basic understanding of what the properties of this gas were. I had purchased out of my own pocket for $1,500, a smaller Brown's gas unit than the ones that we were using for the larger experiments, which were thousands of dollars. And this was made in the Mongolian Metals Institute in China. But it was a very powerful torch, and you could do all kinds of things with it. And I had an associate at that time who had a PhD in physical chemistry. And he got us into a university, and I'm not going to mention any names. It was in Ohio. I'll give you that much. And because of his influence with that organization, we got to pass pure Brown's gas from this particular gas generator through a gas spectrometer. And it did an analysis on that and spit it out. And that turned out to be phase shifted water. And I don't understand exactly what the phase shifting means specifically, but the identity and the molecular weight of the gas was the same as water vapor, but the bonding characteristics were entirely different. I believe they were ionic. And this phase shift thing seemed to indicate that there was a change in the angle, which I think is normally 102 degrees between the hydrogen bonds and the oxygen, to almost 180 degrees. And that alone gave it completely different properties. And so, and the molecules were huge. They were much larger. Now, I don't know anything about what determines the size of various molecules, but the fact that the work that I did with Brown's gas and vacuum systems definitely told me that there was a huge difference in molecular size between a normal water molecule and a molecule of Brown's gas. And we built all kinds of equipment that worked on this principle. And Brown was very fertile in that regard. I mean, he envisioned submarines that were powered by this. If you've seen that movie, Hunt for Red October, where they're talking about the Caterpillar drive. Well, Brown's gas would make a really interesting Caterpillar drive, and it wouldn't even be magnetohydrodynamics that was doing it. It was a much simpler process. He also confided in me, he being Brown, that while he was a guest of the Chinese government, and he was in Mongolia working at this Metals Institute where they developed the design for these gas generators. He was there for several years before he came to the States. And the reason he left was because the Chinese wanted him to use his knowledge of Brown's gas to develop a weapon system. And I won't even tell you what that was, but he was at that point turned off to working with them, and he left. I'm surprised they let him leave too, but he got out. And then he went to Australia, and then he came to the US. So it's a very interesting and convoluted story.
So in the early days, if I'm understanding you correctly, Jim, is the Brown's gas systems were used to make a fuel source to drive motors, drive engines, drive machines. Is that the original applications?
I'm not sure what they did in China or Mongolia, but we did that. I can tell you, I mean, I was there. We had a huge machine that I forget how many cubic feet of Brown's gas per minute it was capable of, but it cost this guy whose name I refuse to mention a pretty penny, and we had several of them, and we put them in parallel and used them to drive car engines with no real trouble. The biggest problem with doing that, by the way, was the fact that the gas is so fine that a lot of it blew right past the normal piston seals in a standard engine and wound up down in the oil sump. And so it was very hard to keep compression with a normal set of rings. And we had to make adjustments for that. We had a few engines blow up on us because of that. That became a standing joke around the place. But once we licked that problem, it was very interesting because we could run the engines and the exhaust was almost pure water vapor. And they produced, we didn't have the luxury of a dynamometer, but for all intents and purposes, considering the speed and the loads that we put on it, it looked like it was comparable horsepower to what the motor was designed for. But it did consume a heck of a lot of gas. And the other things that we learned that were fascinating was that you could do some amazing things with the flame of Brown's gas. Burning in air, a well-adjusted flame from a properly designed Brown's gas machine operates at 212 degrees. That's the heat of the flame, believe it or not. But what's really amazing is that if you impinge that same flame on a target that has a higher atomic weight than the air in which the flame is burning, the temperature immediately goes up without you changing anything.
Oh.
Give you an example. A target of tungsten immediately vaporizes at over 6,000 degrees from the same flame that you can put your fingers in at 212 degrees, as long as you don't leave them there. And that's pretty amazing, the fact that that can happen. Brown told me that one of the things they did in China was that they built a, I guess you would call it a Brown's gas furnace that I don't know how it was actually designed, but the nozzles that introduced the Brown's gas into the furnace were made of some exotic material, and the target was a tungsten wire that was automatically fed into the flame. And the combination of that tungsten wire and that Brown's gas flame produced 6,000 degrees, which was then transformed into superheated steam and used to run a turbine. And apparently it was way more efficient than using, coal or any other fuel to generate the same amount of electricity. So I thought that was pretty amazing. And then the ability for that same flame to weld peculiar objects together. Like you could weld metal to stone. I did that myself many times. And you could also put a flame spreader on there, and you could take an ordinary brick, like the kind that masons use, in the foundation of houses, for instance, and you could run the Brown's gas across that, the flame of the Brown's gas across that, and it would turn it to glass on the outside.
Wow.
Which would increase its weatherability and its ability to resist corrosion and everything.
Insulation too, probably, right?
Pardon?
Insulation as well, I would think.
Oh yeah, I would imagine. And then there were other little things. They'll come to mind as we chat. But another big thing. That physicist that I went into that university with in Ohio, we did some experiments in his laboratory with Brown's gas flames coming from a torch. And under certain filters that you could view the flame with, you could see some amazing things. And one of them that I noticed was the flame, when it was viewed through this particular filter, and I don't know what the filter was, that was basically his secret, allowed you to see that the flame itself consisted of an endless series of little V-shaped patterns of light coming out of the, or internal to the flame itself. And according to this guy was that that was indicative of the fact that the propagation rate was supersonic on this flame front, that it burned at such an ungodly speed that it was actually a supersonic flame.
Wow.
And so, we did a lot of interesting experiments with that.
Do you know if anyone's doing this sort of thing commercially today, using Brown's gas generators in those sorts of applications? I mean, I've never come across anyone using them, but I've heard about it. But
well, the Chinese were definitely selling them commercially, and they still are, as far as I know. You can fill a tank up with water and do the same work that you could do with oxyacetylene for a tenth of the cost.
Yeah.
But there are vested interests that don't like that idea.
Yes, absolutely. But I mean, it seems to be verging on. You mentioned alchemy earlier, Jim, and some of the properties of what's going off there seem to be sort of verging on alchemical things. It seems really weird.
Well, I could take it further than that for you. Brown was very, very adamant about the fact that you could take a radioisotope and place it in a Brown's gas flame, and if you had enough heat to melt it, and then you irradiated the melt, that you would essentially get rid of 90% of the radioactivity. Now, unfortunately, that was so unbelievably suppressed that we weren't even allowed to do an analysis of the isotope after the treatment, which would have told us whether or not there was truly transmutation going on. But I assume there was, because I do know from other tests that we did that the flame is exceptionally rich in free neutrons, which makes a lot of sense if you consider how it's produced. But that would be in itself a monumental thing. And, you know, it's the same old story. How can something so wonderful be so badly treated? And Brown was a little bit crazy in some respects. He used to carry radioisotopes in his pockets because he was always ready to do that experiment, to show it to somebody, you know. And I said, aren't you a little concerned about the nearness to your genitalia? I said, nah, I don't use it anyway.
I thought you tell David what he died from.
Yeah.
Yeah, well, he did die of cancer, but I think it was lung cancer. I'm not sure.
Oh, I thought you said it was testicular, which
It
makes
might have been both. I don't know. Well, you know, one goes to the other very quickly. So
Yes. But I suppose one of the amazing things probably is genitalia did glow in the dark, so you could always find him.
yeah, well, not if he was wearing pants. But I will have to tell you sometime a story about glowing in the dark. But it's such a departure from this conversation that I don't think it's warranted right now.
Probably off air, we can talk about that. Yeah.
Yeah, sometime when we're right in the same room.
Yeah, I understand. I understand. Well, it seems, I mean, it's incredible. I mean, both, well, I believe you have one now, Jim. I mean, both Ira and I have a Brown's gas machine, but we don't use the torch parts of it. Well, not yet, at least, anyway. We tend to use it for other reasons, for, I don't know what we can say, for health reasons, because it has some quite amazing properties with that, not least of which is what appears to be cold plasma that gets produced during the process of electrolysis, which seems to be, as Ira and I often say, where the magic is when it comes to what you inhale and the way that it affects the body. So we're both experimenting with that as we speak, as it were.
The most important question, Jim, is where are you hiding the gold bars?
Gold bars.
Yes.
If I had gold bars, I'd be spending them on my research.
Yeah, I'm sure. I'm sure. Yeah.
I thought you were saving them as a Christmas present for me, but it's okay.
Well, I'll tell you about that later.
Christmas present, but I don't think it'll be quite that valuable.
Okay. Well, I mean, that's fascinating stuff, really. So, I mean, I think, am I right in saying, Jim, have you met or had anything to do with George Wiseman, who produces Brown's gas machines? In fact, he produces the ones that both Ira and I have got, and I think that you've got. Have you actually met him or spoken to him at all?
No, not yet, but I'm looking forward to doing so.
And we can arrange that.
We'll set that up. He's a really nice guy, very knowledgeable too. But yeah, that will be an interesting conversation.
That's something that we should probably have in private before we air it, though.
Yes, I think so. I think so. Yeah.
So anyway, with respect to the Brown's gas that that I have actually experienced with, it was almost all heavy industrial stuff. this will be my first exposure to the health aspects of it. Although Brown did tell me that, to his knowledge, and I'm not sure which Navy he was talking about now that I ponder the issue, but he said that he was aware that deep divers were using a Brown's gas mixture in their breathing apparatus. And that was pretty interesting
Yeah.
realization.
Yeah. I've sort of heard, I think it was you, Ira, that had told me about that.
Yeah.
I'd never come across that before.
Yeah, one of
Which,
the guys that George was talking to, I don't know if he was a doctor or not, but he was from the UK, and he was trying to get the government to approve this, and the insurance would pay for it for health purposes. And one of the things he said is that it's impossible to patent this stuff because divers have been using it for God knows how long. And I think he was referring to the deep bell divers, whatever they call them. So that obviously is true.
is it, I mean, I've never heard of them using it, but then I've never been associated with sort of scuba diving or anything like that, so I don't know. But I'm just wondering if one of the magical properties, if you're breathing that, is that you couldn't suffer from what they call the bends,
Yeah.
which is quite a dangerous, well, it can kill you, can't it? And maybe, yeah, maybe you don't get that, because I think that's when you get nitrogen in the blood, is
Mhm.
it that causes the bends? And yeah, okay. Well, something we can look at. Not that I'm planning on doing that myself, of course, but it's interesting to know these things.
Yeah, I
Oh,
think it can cause an embolus, from the pressure, and then the embolus can block blood flow to the brain or whatever, and that can cook you.
Yeah.
So
Yeah.
not fun.
Okay. Well, we've been going for about 2 hours now, so I'm sure probably Jim's had enough.
well, I don't have any problem with going along, speaking about all these things because they're fascinating and I love talking about them. But I think that there's a limit as far as viewers are concerned.
Yeah, yeah, yeah.
Well,
And I think,
we're going to do other things. Obviously, we'll get set something up with you and George, and we'll record that too, and that'll be a whole other chapter in this, and a few other people too who love to talk with you about this stuff. Not just the Brown's gas, the whole Tesla thing.
Yeah, I'm happy to do that.
I know.
okay,
So we're lucky to have you.
yeah. Well, I think if you've no objections, we'll wind it up here. And I thank you very much for your time, Jim. It's been most interesting. And I'm sure we'll chat again. So if you want to hit the stop record, Ira, and we'll
I
go off
will.
there. So thank you, everyone, for
Stay on
listening.
1 second, Jim, though. I'll hit the stop record.